Welcome to another edition of Math for No Reason. In this edition, we discuss a new proof of the well-known fact that there are an infinite number of primes. This proof is due to Northshield and is known as the one-line proof of this celebrated result. The fact that there are infinitely many primes has been known for a very long time, and it dates back at least to Euclid. And there are many alternative proofs that are available. The proof that we will discuss here is quite simple and elegant, and of course it is a short proof, and that's why we are going to spend some time discussing this. Let us begin with the assumption that there are only finitely many primes, and let's call this P1, P2, Pn, and let capital P be the product of all these primes. Now note that for every prime P, we have 0 to be less than pi by pi less than equal to pi by 2. Note that 2 is the smallest prime and all primes are greater than 2, and therefore pi divided by pi is less than equal to pi by 2 for every prime pi. Now since all of these primes are greater than or equal to 2, therefore pi by pi, all of them lie in the first quadrant, and we know that the sine function is positive in the first quadrant. So sine pi divided by pi is strictly positive for all these primes pi. And thus, when we take a product of these positive numbers, we actually get that to be also a positive number, and therefore the product of I is equal to 1 to n sine pi divided by pi is strictly greater than 0. This is an important fact to remember. Now we will show that this quantity I is equal to 1 to n sine pi by pi is equal to this more complicated quantity written on the right hand side, which is the product of I is equal to 1 to n sine of pi into 1 plus 2 capital P divided by pi. Now what is capital P? Recall that capital P is P1, P2 up to Pn, the product of all the primes. Now if we look at this quantity pi into 1 plus 2p divided by pi, we can write that as pi divided by pi plus twice pi capital P divided by pi. Remembering that capital P is a product of all the primes, we note that p can be written as pi into mi for some integer mi, and thus we can write pi into 1 plus 2p whole divided by pi as pi divided by pi plus twice pi mi. Now recall that sine is periodic, and sine of theta plus twice pi k is equal to sine theta for any integer k. And that comes in very handy here, because we can then write sine of pi divided by pi plus twice pi mi as nothing but sine of pi divided by pi. Note that this holds for every prime pi in our finite set. Hence, if we take the product of I is equal to 1 to n sine of pi into 1 plus 2p whole divided by pi, that quantity is same as product of I is equal to 1 to n sine pi by pi. We have already seen that the quantity on the right hand side is strictly greater than 0. Now let us try to compute this quantity in another way. Now we observe that all of these primes pi is less than 1 plus 2 times p. Since these are the only primes, therefore this number 1 plus 2p is a composite number, and hence this should be divisible by one of these primes pi. Now, since this is divisible by one of these primes pi, we can think of the prime q, which is one of these pi's, actually divide this quantity 1 plus 2p. So we can write pi into 1 plus 2p by q as pi times kq. This is a very interesting observation, and also note that here this quantity kq is an integer. So when we consider sine of pi into 1 plus 2 capital P by q, which is the same as sine of pi into kq, we know that this is equal to 0 because for all integer multiples of pi, sine takes the value 0. So sine of pi kq is equal to 0. And therefore, we will have the product of I is equal to 1 to n sine pi of 1 plus 2 capital P whole divided by pi is equal to 0. Now that is a contradiction, since we have already noted the product of sine pi by pi is strictly positive, but now we have shown that that is equal to 0. So we are arriving at 0 less than 0. So therefore we have a contradiction here. And what is the contradiction to? It's a contradiction to our assumption that there are finitely many primes. And thus we can conclude that there are infinitely many primes. It's been known to mankind since the time of Euclid. And this is how Northshield had written the proof, which is basically just one line. So that's why this is called the one-line proof of the fact that there are infinitely many primes. Thank you very much.